Okay, so in today's lesson, we're going to talk about solving quadratic equations. And these quadratic equations are going to be solved by factoring. Now, let's talk about the equations that we solved on test 1. So on test 1, we solved linear equations. So these were linear equations. Now, the ones that we had on test 1 were more complicated than the one I'm about to show you. But the point is this. So this is a linear equation. So, for example, x minus 3 equals 0. That's a linear equation. Now, remember, a linear equation has the form ax plus b equal 0. Something like that. All right, so ax plus b equals 0. And remember, what made this linear was for one thing, that the largest exponent here is 1. All right, so this looks like this. So we have this form. So a in this case, the coefficient of x is 1. B in this case is negative 3. And we have 0 on the other side. Okay? So that's a linear equation. Now, when we solve this linear equation, remember we added 3 to both sides. And so we got x to be 3. So that was the solution. And remember, this linear equation has one solution. It is 3. When x is 3, 3 makes this equation a true statement. So 3 minus 3 is 0, and 0 equals 0. So that's a solution. Okay, now, for a quadratic equation has this form. So this is a quadratic equation. So a quadratic equation has this form. All right, equation, I-O-N, has this form. ax squared plus bx plus c equals 0. That's a quadratic equation. That's the form of a quadratic equation. All right, now, in this quadratic equation, the coefficient of x squared cannot be 0. So I'm going to see why a cannot equal 0. So b can be any real number, c can be any real number, and a can be any real number except 0. Because if a were 0, 0 times x squared 0, notice that this would be in the form of a linear equation. bx plus c equals 0. So that would be a linear equation. So if we're talking about a quadratic equation, we have to have the largest exponent being 2. So that's what makes this a quadratic equation. The largest exponent is 2. Now, one important thing when you're going to solve an equation, a quadratic equation by factoring, we want this quadratic equation, whatever your quadratic equation looks like, whatever order it's in, we want it to be in standard or general form. So let's say this is in standard form. Some textbooks will use the word general. Some will use the word standard. But basically, you're going to have all the terms on one side, 0 on the other. That's going to be important. 0 on the other. So you want 0 on this side. And I also want these terms to be in descending order. Descending order. All right, so descending order means you go from largest exponent to smallest. So if you notice this term here, the largest exponent is 2. This term, the exponent is 2. This term here, the exponent is 1, and then we have our constant. So remember, the constant is a term that doesn't have a variable associated with it. So it's always going to be this constant. This term is always going to be c, whatever c may be. So for example, let's talk about descending order. So let's put, 2x minus 5x squared, let's say plus x squared, minus 3 equals 0 in descending order. Okay, that's going to be important when we factor descending order. All right, so notice that I have 0 on the other side, which is what I wanted. I need a 0 on this side, but I need this to be in descending order. So notice there are 3 terms. One term, the first term listed is 2x. The second term listed is 5x squared, and the constant is negative 3. So if I put this in descending order, I get 5x squared plus 2x minus 3 equals 0. That's descending order. Descending order. So notice that the term that has the exponent 2 is listed first. The term that has the exponent 1 is listed second, and my constant is listed third. Okay, so it's really important that you write this in descending order. Okay, now let's look at a particular example of a quadratic equation, and we're going to solve this quadratic equation. Now, so I'm just going to write this down. I'm going to solve, and these are going to be quadratic equations. So the first one's going to be easy. Here's the first one, x squared minus 9 equals 0. And so remember, when solving an equation, you're trying to find the values of x that will make this equation a true statement. So you want this side of the equation, whatever you let x be, you want this side to equal this side. So you need these two sides to be 0. Okay? So you can look at this and notice that if x is 3, so x equals 3 is a solution. All right, x equals 3 is a solution, because when I substitute 3 into the equation, I get 3 squared is 9, 9 minus 9 is 0. So that's a solution. But can you look at can you think of another solution? Is this the only solution? So remember, when we solved this linear equation, that was only one solution. That 3 was the only number. 3 is the only value of x that will make this equation a true statement. Now remember, that was a linear equation. Now this is quadratic. Can you think of another number, another value of x, that will make this side equal to 0? And so if you said negative 3, you're correct. X equal negative 3 is also a solution. And I want you to see this. So let's check. Let's check x equal negative 3. So if I go back to the original equation, you must always go back to the original equation. And if I substitute negative 3 into x in the place of x, so I get negative 3 squared. Notice I put parentheses. Parentheses are important here. Minus 9, and I want to see if that's going to equal the other side, which is 0. Well, negative 3 times itself is 9, and 9 minus 9 does equal 0. So notice that this quadratic equation, this is quadratic, because the largest exponent you see is 2, even though the term with just the variable x is missing, it's still quadratic. It has 2 terms, but it's still quadratic because the largest exponent is 2. Notice that this quadratic equation has 2 solutions. All right, now, the thing is, though, that you're not going to be able to guess at the solutions like you were able to guess here. All right, so it's not that simple. All right, now, here's something that's going to be important. If you're going to solve a quadratic equation by factoring, there is a skill that you're going to need to know how to deal with. You're going to have a skill you're going to need to know how to use. All right, so let's think about this for a moment. Let's suppose I have 4 times some number, and I'm telling you that that's equal to 0. So 4 times some number equals 0. Okay? Well, notice that this is a product, and it's a product of 2 factors. My factors are 4, and the other factor is whatever this is. All right, so if my first factor is 4 times what number? So what must this factor be here so I can get a product of 0? All right, so don't make this difficult. It's a very simple question. 4 times what is 0? Well, the answer is 0. Okay, so that's going to be important. So whenever you have 2 or more factors whose product is 0, then one of these factors must be 0. Then one of the factors must be 0. Okay? So that kind of makes sense because look, if I have some factor times some factor times some factor equals 0. So let's say I have these whatever these are, whatever factors these are. If these three factors equal to 0, then one of these has to be 0. Either this is 0, or this is 0, or this is 0. One of them has to be 0 because that's the only way I can get a product of 0. All right, now this is important. What we just discussed is important when we solve an equation by factoring. So whenever we're going to solve an equation by factoring, we're going to use this idea. This idea will always be used. Now this idea, there's a name for it. It's called the zero factor property. Zero factor property. And here's what the zero factor property says. If you have two factors, a times b, and that product is equal to 0, then one of these has to be 0. So then you would say either a is 0 or b is 0. So either the factor a is equal to 0 or the factor b is equal to 0. So that's called the zero factor property. Whenever you're solving a quadratic equation by factoring, you are going to be using the zero factor property at some point. All right, now you may say, well, how do I use the zero factor property in a quadratic equation? Let's look at number 2 for a moment. Suppose I had this. Suppose I had, I'm going to make this a simple one so you can kind of guess at the answer. Suppose I had x minus 5 times x minus 2, and I'm telling you that that product is 0. Now I want you to notice this. You dealt with a whole chapter on factoring, so I want you to notice that if you were to FOIL this out, because I have two binomials and a multiply, I'm just going to FOIL it out just to show you what you're going to get. X times x is x squared. The outer is a negative 2x. The inner is a negative 5x. And the last, a negative 5 times a negative 2 is a positive 10. And so when I combine like terms, I get x squared minus 7x plus 10. And I want you to notice that that's equal to 0. So what I want you to notice, the whole point of me doing this was to show you that this right here is the same thing as this, and that's a quadratic equation. That's a quadratic equation. And so notice whenever we solve a quadratic equation by factoring, you got to make sure that your quadratic equation, the expression that's quadratic, is factored. So do y'all see that in number 2, this quadratic equation has already been factored for you? Okay? Now think about what I'm about to say. So this side, this quadratic equation, I want you to know that this was quadratic because when you multiply x times x, you get x squared, and that's going to be quadratic. Notice that this quadratic equation is already factored, and so the question is, how many factors do you see? Tell me what the factors are. You have to be able to determine the factors. Well, my first factor is x minus 5, and my second factor is x minus 2. And so then I'm going to ask you, you are told that these two factors multiplied together is 0. Based on this, if that's true, if this product is equal to 0, is indeed equal to 0, and it is, because the way it's written, then one of these factors has to be 0. So if I look at this right here, so if I cover this part up right here, you'll notice I'm going to ask you this. What value of x makes this factor equal to 0? So you have x minus 5. What minus 5 is equal to 0? So if you said 5, you're correct. So that's one of your solutions. So basically, remember we said you're going to set each factor equal to 0. So what's my first factor? Well, my first factor is x minus 5. So you're going to say x minus 5 equals 0. What's my other factor? You do all factors. My other factor is x minus 2. So x minus 2 equals 0. And so I want you to notice that I went from a quadratic equation, this is quadratic, it's this right here, to two linear equations. You went from a quadratic equation to two linear equations, and you solve a linear equation just as you did in previous courses. And so to solve this linear equation, I'm just going to add 5 to both sides, get x by itself, and I have one of my solutions. One of my solutions is x equals 5. Over here, I add 2 to both sides, and so my other equation is x equals 2. All right, now, so those are your solutions. So notice there are two solutions. Two values of x makes this a true statement. All right, you can check it. Let's check the first one. Check x equals 5. Now remember, always go back to the original. So if I let x equal 5, notice what I get. Wherever you see the variable x, I'm going to substitute 5. So I get this. I get 5 minus 5 times 5 minus 2. And I want to see if that's equals 0. Well, what's 5 minus 5? Well, 5 minus 5 is 0. What's 5 minus 2? Well, 5 minus 2 is 3. Is that product equal to 0? Is 0 times 3 equal to 0? The answer is yes. So 5 is a solution. And you do the same thing with 2. So if you check x equal 2, if you check that solution to make sure what you have is correct, again, you go to the original, and where we see the variable x, and I see it listed twice, I substitute 2. So I get, in place of x, we substitute 2, so I get 2 minus 5 times 2 minus 2, and I want to see if that's going to equal 0. Well, 2 minus 5 is a negative 3, 2 minus 2 is 0, and so I'm going to ask you, is negative 3 times 0 equal to 0? And the answer is yes. So x equal 2 is also a solution. Now, do you have to check? No. You don't have to check any of these, but you could easily make a mistake, so it's always a good idea to check to verify that you did not make an error. Okay? Now, let's look at number 3. So there's going to be number 3. So number 3, let's suppose we had 3x minus 5 times, let's make it 3x plus 4. 3x plus 4 times 2x minus 3, and that product is 0. So again, I'm going to ask you, can you tell me what kind of equation this is? And all you've dealt with so far were linear equations. You've dealt with linear equations and quadratic equations. Okay, that's all you've dealt with at this point. Linear equations, quadratic. So the question is this a linear equation or is this a quadratic equation? Well, notice that these are two binomials, so if I FOIL this out, and I'm not going to FOIL it out, but I just want you to notice, if you look at the first, what's 3x times 2x? Well, 3x times 2x is 6x squared. So that makes it quadratic. So that's made a quadratic equation. All right, now, notice that this quadratic equation is in factored form. So notice I have how many factors here? How many factors are being multiplied together? Well, there's this factor, 3x plus 4, and then there's this factor, 2x minus 3. Well, remember, if I have a product of factors and that product is 0, then one of these, how many do you see? You see two of them. 3x plus 4, so either 3x plus 4 or 2x minus 3 has to equal 0. So remember, that's called the zero factor property. So according to the zero factor property, either this factor is equal to 0 or this factor is equal to 0. And then notice again, just like this, I went from a quadratic equation to two linear equations. And so I just got to solve this linear equation. So the solution to this linear equation is the solution to this quadratic. The solution to this linear equation is a solution to the quadratic. So I'm going to subtract 4 from both sides. So I get 3x equal negative 4. And then divide both sides by 3 to get the variable x by itself. I found one of my solutions. So one of my solutions is a negative 4/3. That's one of your solutions. And then if I go over here, if I add 3 to both sides, I get 2x equal a positive 3. And if I divide both sides by 2, I get x to be 3/2. So that's the other solution. So this quadratic equation has how many solutions? Well, there are 2, -4/3 and a positive 3/2. And again, if you want to check this, always go back to the original. So here was the original. I'm going to write the original over. So here is my original. 3x plus 4 times 2x minus 3. That's my equation, equals 0. So I want to check the first one. Let's check x equal -4/3. So whenever I see the variable x, I'm going to substitute -4/3. You've done that before. So I get this. I get 3, in parentheses, 3 times x. X is a -4/3 plus 4 times 2 times x. X is a -4/3 minus 3. And I want to see if this product is going to equal 0. All right, well, let's look at this parentheses first. So notice inside the parentheses, this parentheses, I have a product and an addition. You do multiplication first. So you got to remember 3 times a -4/3. You're multiplying these two fractions. So you're going to reduce first. And so I get 1 times a -4 is a -4. So this becomes -4 plus 4 times. Now, I'm going to show you that I'm not even going to worry about this for right now because 2 times a -4/3, which, remember, that's 2 over 1. So some students have trouble with this. They'll say that's a -8/6. That's not true. That's not -8/6. Because if you look at this, that's 2 divided by 1, so you multiply the numerators and then multiply the denominators, so that's -8/3. But the point's this. Whatever this is, and you could figure it out, the LCD is 3. Whatever this is, it doesn't matter because the point's this. -4 plus 4 is 0, and 0 times whatever this is equal to 0. So x equal -4/3 is 0. And the reason why it's a solution because it makes this factor equal to 0. Whatever -4/3 makes this equal to, this is going to be 0, and 0 times whatever this is equal to 0. All right, now if I do the other one, let's check the other solution, x equal, and I think it was 3/2, x equal 3/2. And you're going to use that same idea. You know that's going to be a solution. And the reason you know this works is because which of these factors becomes 0 when you substitute 3/2? If we said this one, you're correct. Because if I actually do the substitution, I get this. I get 3 times 3/2, remember x is 3/2, plus 4, times 2 times 3/2 minus 3. 2 times 3/2 minus 3. And I want to see if that's going to equal 0. So I want to look at this in particular, this right here. So remember, do multiplication before you do subtraction. 2 times 3/2, remember that's 2 over 1. The 2's reduce, and you get 1 times 3 is 3. So whatever this is right here, and by the way, 3 times 3/2 is 9/2. 3 times 3 is 9. And then you have, this is over 1. 1 times 2 is 2. So that's 9/2 plus 4 times 3 minus 3. And I want you to notice that this is 0. And 0 times this right here is still going to equal 0. All right, so you found the solutions, and the solutions do work. So those are those you checked the solutions, and you did not make a mistake. Those are your solutions. All right, now I want you to notice in numbers 2 and 3. Remember, the directions were solve a quadratic equation by factoring. I want you to notice that in 2 and 3, in numbers 2 and number 3, it was in factored form already. So it was already factored. It was already factored. All right, so let's look at number 4 now. All right, number 4. Number 4. Suppose we had this. Okay, that's number 4. Suppose we had x squared plus 15x equal 0. X squared plus 15x equal 0. All right, so notice this is an equation. A question you got to ask yourself is, what kind of equation is this? Is it linear or is it quadratic? Because that's all you've had so far. Those are the only equations you've had at this point. Well, it's quadratic, because if you look at the larger exponent of the two terms that you see on the left-hand side, it's 2. So it's quadratic. And so remember, we want to solve this quadratic equation by factoring. All right, so here are going to be the steps. So step 1 is you're going to have to write it in standard form. Right? In standard form. So remember, standard form is where you have something that looks like this: ax squared plus bx plus c equals 0. So you need 0 on the other side, all the terms on one side. And it already is. And also make sure it's in descending order. Descending order. All right, so it is in descending order. X squared plus 15x equals 0. All right, step 2. So step 2 is this right here. So step 2 is where you end up with this idea. So remember, this was in factored form already. So step numbers 2 and 3 were in factored form. So step 2 is to factor. Step 2 is to factor. So factor, in this case, will be the left-hand side. So factor the quadratic expression. Okay, factor the quadratic expression. All right, so let's think about how to factor x squared plus 15x. What's the first thing you got to do when you're factoring a polynomial? So remember, the first thing you need to do in factoring a polynomial is to find the GCF. Now, all polynomials have a GCF. It's 1 or something else. So in this case, if you look at these two terms, the GCF is x. So I'm going to factor out an x. I get x times x plus 15 equal 0. So I factored. Now, it doesn't look like this, like the two binomials, because if you had the two binomials, it would be a trinomial. Or, well, if it's the difference of two squares, it would be a binomial itself. But if you have two binomials, notice in both cases, if you were to multiply these out, you would get a trinomial. So this is not a trinomial, though. So you need a, chances are, you're going to factor out a monomial factor. Now I want you to notice, how many factors do you see? What are your factors? Well, if you said this is one of my factors, you're correct. X is a factor. If you said this is the other factor, you're correct as well. So how many factors do you see? There are 2. X is the first one. X plus 15 is the second one. Now, do you remember what property you're going to use? Think about how we did numbers 2 and 3. Once it's factored, what was the next thing we did? Well, we said each factor equal to 0, because that's the only way you can get a product of 0, if one of these was equal to 0. And that's called the zero factor property. So the next step then is this. So step 3 is to solve the equation using the zero factor property. All right, so you could break this down into 2 steps as well. So you could say, well, next I'm going to use the zero factor property, and then I'm going to solve each linear equation. All right, I just put those 2 things in one step. All right, so you're going to say x equals 0, and you're going to say x plus 15 equals 0. And notice I went from a quadratic equation to 2 linear equations. Now this confuses students, because every time you solve a linear equation, you have to do something to it. So for example, here I'm going to subtract 15. I did something to it. I used the addition property of equality. So then I get x to be negative 15. But here, there's nothing to do, because you got x is already by itself. So one of your solutions is 0. That's one of your solutions. But that does confuse students, because they think that 0 cannot be a solution. Well, it can, because if you check it, look, remember, always go back to the original. So let's check 0. So those are your two solutions, by the way. So let's check x equals 0. Again, always go back to the original because you could have made a mistake here when factoring. Go back to the original. So we get x squared plus 15x equal 0. So where we see the variable x, I substitute 0. So I get 0 squared plus 15 times 0, and I want to see that's equal to 0. What's 0 squared? 0 times 0 is 0. 15 times 0 is 0, and is 0 plus 0 equal to 0? The answer is yes. So 0 is a solution. If I do negative 15, if I check x equal negative 15, again, you go back to the original. So I get negative 15 in parentheses squared plus 15 times negative 15, and I want to see that's going to equal 0. All right, so negative 15 times a negative 15 is a positive 225. A negative 15 times a positive 15 is a negative 225. And notice 225 minus 225 is equal to 0. Okay? All right, now, so that was number 4. All right, number 5. Let's suppose we had this for number 5. We had, let's see, let's suppose we had x squared minus 5x plus 6 equal 0. So x squared minus 5x plus 6 equal 0. All right, so again, you got to ask yourself, what kind of equation do I have? Is it linear or is it quadratic? Because that's all you dealt with. Well, if you say quadratic, you're right, because your largest term, and I should say largest term, I mean the highest degree term is 2, right here. So your exponent's 2. Now again, if that wasn't there, then all you'd have is this, and that would be linear. Okay, but the fact that this is x squared makes it quadratic. Then you remember, you got to make sure that it's in standard form. So is this in standard form? Yes. Do you have 0 on the other side, and all the terms on the left side are on one side? It doesn't have to be left, it could be on the right or the left, but as long as 0 is on one side and your terms are on the other side, the quadratic expression is on the other side, and let's put in descending order. So this is already in standard form. Okay, the next step is to factor. Okay, look for GCF first. So the GCF here is 1. So then, now since this is a trinomial, I'm going to go and factor this two binomials. See, this was not a trinomial, this was a binomial, and it turned out that the GCF was x, and so I factor out an x. All right, here, the GCF is 1, it's a trinomial, so I'm going to do the two binomials. So when you factor this, you're going to get x for 6 will be 3 and 2. Let's check that first. And then the last sign's positive. So that means these signs in here are the same. It'll be the middle sign. And again, before you go on, just like you did in the previous chapter, check, because you want the middle term to be a negative 5x. So that's the outer and the inner. So if you look at the outer is a negative 2x. The inner is a negative 3x, and when I add them up, I do get a negative 5x. So this is factored correctly. So that was step 2. So step 2 is to factor. Now, remember, what do you think is going to be the next step? What property are you going to use next? What property is going to be important at that point? Well, if you said the zero factor property, you are correct. So notice, what are my factors? How many factors do you see? There are 2. There's this factor here. I'm going to underline it. And there's this factor here. And that product is 0. The only way this product can be 0 is if one of these, either this one or this one, is equal to 0. And so now the next step is to solve the equation. So I use a zero factor property, and now I'm going to solve each linear equation. So I went from a quadratic equation to 2 linear equations. So then one of my solutions is x equal 3, and the other solution is, I'm going to add 2 to both sides, x equal 2. So those are your 2 solutions. And again, I want to go ahead and check this. So let's check x equal 3. Now again, I'm going to repeat this again. Always go back to the original. Don't go back to the factor one because you could have made a mistake. You could have said x plus 3 times x plus 2. But the solutions here would not be the solutions here if you did do that. X plus 3 times x plus 2. Because in that case you would get a negative 3 and a negative 2, and those are not the solutions to this. It's solutions to the incorrect factorization, but not this one. So always go back to the original. So if I substitute x equal 3 in the original, I get 3 squared minus 5 times 3 plus 6, and I want to see if that's going to equal 0. Well, 3 squared is 9, minus 5 times 3 is 15, plus 6. 9 minus 15 is a negative 6. Negative 6 plus 6 is indeed equal to 0. And if you did the same thing for 2, you would see it would work out. Okay? All right, let's do one more with this. And we'll do more with this. So this is a mini lesson on solving quadratic equations by factoring. So the whole point here was to introduce the zero factor property, and know when to use it. All right, let's look at one more. So let's look at number 6. Number 6. So number 6, suppose you want to solve this equation. 9x squared plus 7x equal 2. 9x squared plus 7x equal 2. All right, so first of all, you got to remember to solve this quadratic equation, it must be in standard form. The only way you can use a zero factor property, because remember we said a while ago, whenever you're solving a quadratic equation by factoring, you will always use the zero factor property. Well, if I'm going to use a zero factor property, then I better have 0 on the other side. You can't have any other number. You can't have 1, you can't have negative 2, you can't have 1/4. The only real number you can have is 0. So do not make the mistake and factor this and set each one equal to 2. Do not do that. That factor property is called the zero factor property. It's not called the 2 factor property or the 3 factor property. It's called the 0 factor property. Okay, so you got to have 0 here. So the first thing you got to do is put it in standard form. And remember this is quadratic, write the quadratic equation in standard form. So I'm going to go ahead and subtract 2 from both sides. And so I'm going to get 9x squared plus 7x minus 2 equal 0. And so it's in descending order. So, and the GCF of the quadratic expression is 1. So now I'm going to go directly to the 2 binomials. And don't forget, you got to say equals 0. That's one of the things I got to remind you. At every point, I want you to notice, you have to say equals 0, equals 0. You gotta actually say this is equal to 0, this is equal to 0. You can't not say x minus 5 and then say x is 5. You gotta have an equation. Okay, so when I did number 4, let me go back to number 4. When I did number 4, I not only factored this, but I made sure it was still an equation. You have to say equals 0. You can't just factor and then all of a sudden say x equals 0, x plus 15 equals 0. You gotta say, when you factor, you gotta say equals 0. So make sure every statement you make is mathematically correct. Okay? All right. Now, here's a mistake that some of you are going to make. So some of you are going to say, all right, I'm going to factor this as 3x minus 1, 3x plus 2, let's say. All right? And remember, when you factor quickly, you could make a mistake. So always check. Always check. Don't try and be in a rush. Check. Okay, so let's check it. 3x times 3x is 9x squared. That's your true statement. A negative 1 times a positive 2 is a negative 2. But remember, you got to check that middle term. What's the outer? Well, the outer, I'm going to go ahead and check it here. 3x minus 1 times 3x plus 2. The outer is 6x. The inner is a negative 3x. And when I add them up, I get 3x. So that didn't work. But let's suppose you forgot to check. Okay? Let's suppose you forgot to check. And so you went ahead, and this could happen. So that's why it's important you check. So I'm showing you what could happen. So this is incorrect. You obviously know that's correct, not correct. Because when I factor this and I FOIL it, I get the outer end to be 3x, and this needs to be 7x. But let's suppose you did not do this, and you go ahead and you set each factor equal to 0. You set each factor equal to 0, and then you solve each linear equation. So you add 1 to both sides, and so I get 3x equal 1, and then divide both sides by 3. And so I get x to be 1/3, okay? And then over here, you subtract 2 from both sides, and so I get 3x equal negative 2, divide both sides by 3, and so I get x to be negative 2/3. But you got to check, because remember, I made a mistake, right? That's not true. But let's check. Let's see, since I made a mistake, what happens when I check it? All right, so here's what's going to happen. All right, so listen carefully. I'm going to get my calculator out. Get your calculator out. Go ahead and get your calculator out. Okay, so I'm going to use my calculator to check this. Always go back to the original. Remember, this was the original. Okay, always go back to the original. Don't go back here, because remember, you made a mistake. So if you check it here, then obviously, yeah, you're going to say, hey, it works because I get 0. Yeah, it does work. Because if you look at 1/3, what's 3 times a third? Well, 3 times a third is 1. 1 minus 1 is 0. And 0 times whatever this is still 0. Yeah, it works because you're not using the original. Always go back to the original. So let's check x equal 1/3. And so wherever you see the variable x, you're going to substitute 1/3. So I get 9 times 1/3 squared plus 7 times 1/3. And I want to see if that's going to equal 2. All right, so here's what I would do. You see, you have fractions. Don't freak out. You have a calculator. Use your calculator. All right, so you're going to say this. And then notice what don't forget the parentheses. I have parentheses here. So as you read it, you type it in. Okay, so notice what happens. 9 times, in parentheses, 1 divided by 3. 1 divided by 3. Close the parentheses. I'm going to square it. So raise to the second power, plus 7 times 1/3, 1 divided by 3, close the parentheses, and then press equal. Do you get 2? The answer is no. You do not get 2. So that just told you that this is not a solution. So that meant that something is wrong here, and you know that something it was indeed wrong. Okay? So it's always going to do, you have a calculator, quickly check it. Quickly check and see if what you have is correct. All right, because you could have easily factored in correctly. Well, if this is incorrect, then I'm not even going to worry about this. I need to go back and redo this part. So let's go back and redo this part. So I'm going to come back here. So the whole point here was to make you aware that even though you factor, what you factor may not be correct. And also the other thing is this. Always go back to the original, because you just saw that if you go back to the incorrect factored part, you're still going to get 0. That's because you got this from the incorrect factors. So yeah, you're going to get 0, but you got to go back to the original. All right, so let's refactor. Let's factor this again. So 9x squared plus 7x minus 2 equals 0. All right, so if I factor it again, obviously 3x and 3x won't work. Switching these, remember, these are the same terms, so it's not going to matter whether I switch the 2 and the 1. So it means that I have to use 9x and x. So 9x and x. All right, so, and the only factors of negative 2 is negative 2, 1, or 2, negative 1. And so what's going to work is going to be this one. All right, again, let's check. 9x times x is 9x squared. Negative 2 times a positive 1 is a negative 2. Now let's see if we get the middle term. Remember, I want this to be a 7x. The outer is a 9x, the inner is a negative 2x, and yes, indeed, I do get 7x. All right, and remember how I said, do not all of a sudden do this. Okay, so you know at this point you have the zero factor property. That's a given. So you're going to say 9x minus 2 equals 0, x plus 1 equals 0. But the point I'm making is this. You see how I have this statement? What am I missing? Do you remember do you think you know what I'm missing? I'm missing the fact that this is an equation, so this must be an equation. So I got to have equals 0. And now I said each factor equals 0. That's a zero factor property that I'm using. And so notice I went from a quadratic equation to 2 linear. So I'm going to add 2 to both sides. So I get 9x equal 2. Divide both sides by 9. I get x to be 2/9. Over here, I subtract 1 from both sides. I get x to be negative 1. Let's just check it. I want you to take your calculator and check 2/9. Take your calculator out and let's check x equal 2/9. Okay, so I know it works here. Let's check and see if it actually is a solution to the original. Now remember this, this was the original. All right, so let's check. So 9x squared plus 7x equal 2. So we see the variable x, I'm going to substitute 2/9. So I get 9 times 2/9 plus, that's squared, plus 7 times 2/9. And I want to see if that's equal to 2. Use your calculator. Don't let these fractions throw you off. Don't do it by hand because it'll take a little bit too long. Use your calculator. So you get 9 times, in parentheses, 2 divided by 9, close the parentheses, square that 2/9. Oops, sorry, I didn't square yet. That's multiplied by 2. I meant to square. So square the 2/9 plus 7 times, in parentheses, 2 divided by 9, close the parentheses, and press equal, and I'm hoping I get a 2. Let's see. Yep, I sure do. So 2/9 is a solution. Now you can check this negative 1 if you want to. X equal negative 1. Go back to the original. 9x squared plus 7x equal 2. So wherever you see the variable x, you can substitute negative 1. So you get 9 times negative 1 squared plus 7 times negative 1. And I want to see if that's going to equal 2. Now I'm not going to use a calculator here because I'm not dealing with the fraction, but I want to do it without the calculator. Remember this, you got to square first before you multiply it. So negative 1 times itself is 1. 1 times 9 is 9, so that's 9. 7 times negative 1 is a negative 7, so you get 9 minus 7. And the question is 9 minus 7 equal to 2? The answer is yes. So those are your two solutions. All right. Now, I want you to notice that before we end this lesson, when I solve this linear equation, a linear equation that looked like this, I had one solution. Now remember, there were some linear equations that you dealt with in the past where you had no solution or an infinite number of solutions. But for us right now, I just want you to realize that this particular linear equation had one solution. And when we solve these quadratic equations, notice that all of them had 2. Now that's not always the case because you're going to see in the next lesson that you could have a double root, meaning double solution, meaning that the factors were exactly the same, meaning that these factors would have been exactly the same. All right, now since the factors are distinctly different, you're going to get 2 solutions. But notice that in both of them you had 2 solutions. 2 solutions, quadratic equation, 2 solutions. In a future course, the degree of this polynomial, in this case 2, will indicate how many roots you would have. So in this case, you would have 2 roots, at most 2 roots, I should say, at most 2 roots, meaning that either some of them are the same or they're all distinct. But that's in another course. All right, so that's going to take care of this lesson. Let's go back over and review this lesson. Make sure you understand what a quadratic equation looks like. What a quadratic equation looks like. Make sure you know that one of the steps is to put it in factored form. Once it's in factored form, then you use a zero factor property, meaning you're going to set each factor equal to 0, and you solve these linear equations, and you have your solutions. So that's it. All right, so that's going to take care of this lesson.